everybody, and welcome to our tour of the universe. My name is Mary, and I work at the Morrison Planetarium here at the California Academy of Sciences. And if you're just tuning in, you are about to see a tour of the universe, which we normally do in the planetarium. Right now, though, while we're doing a tour of the night sky as our daily show at 4:30, we are still bringing you a tour of the universe live online. So we're bringing the planetarium to you in your homes and wherever it is that you are today. And if you have any questions throughout the show, I'm more than happy to try to answer them. Feel free to throw those in the chat if you have anything you want to see. But without further ado, I'm going to just launch right into it, and we are going to get started. And I'm giving our tour of the universe today with a program called OpenSpace, which is a free open source software that you can download at home if you have a powerful enough computer. You can fly around space yourself. And one of the really cool things about it is that it's all based on real data. So it's all free open source data. So all the places we're going to visit are actual images or based on actual data and observations of the places that we're going to go. And we're starting our tour today pretty close to home. We're looking here at the International Space Station, just a few hundred miles above the Earth's surface. And I always like to start out our tours at the International Space Station because it gives us a little bit of perspective on what we're going to see today. Because today we're going to see how far our human influence has gone. We're going to see things like how far have human beings traveled out into space? How far have our spacecraft traveled out into space? How far has anything we've sent out into space gone? And we are going to go much farther than all of that. But the International Space Station, just a few hundred miles above the Earth's surface, this is as far as humans travel out into space right now. You can fit about half a dozen or so astronauts in the ISS at any one time, and it's the largest object that we put out into space as well, about the size of an American football field, or actually about the same size as the Academy building that I'm standing in right now. And I'll bring up a yellow line here so we can see where the orbit of the International Space Station is. They are going really, really fast around us. It only takes about 90 minutes for the ISS to orbit us once, so it goes around really quickly. And you can see in the chat, you can actually look up when the International Space Station is going to pass overhead. So you can just search on that website, spot the station, and see when it's going to pass over. And when it does, it's really easy to see. It looks like a really bright star moving very quickly across the sky. So it's actually really easy to be able to spot. And this is the actual location of the International Space Station right now. Looks like it's flying over the ocean somewhere. Looks like we're missing a little bit of our clouds for some reason, but near the bottom there you can see some clouds. Those are where the weather patterns were this morning. But as we go on our tour today, we're not going to stop any particular place for very long because we have a long way to go. We're going to go as far out into the universe as we possibly can. So we're going to go at a pretty quick pace. So already I'm going to switch our view here, and we are going to visit our closest natural neighbor in space, the moon. Now the moon, this is as far as humans have traveled out into space so far. The Apollo astronauts came out to the moon back in the 1960s and 70s. And when they traveled to the moon, it took a couple of days to get here, because while it is our closest neighbor, it's still about 250,000 miles away from us. So it's very far away. And we do have plans to go back to the moon. The Artemis mission from NASA plans to send people back to the moon. They actually just tested out their spacecraft. Their spacecraft went around the moon and came back. So they're working on sending people back to the moon at some point in the next several years here. But here at the moon is where I like to introduce an idea that I'm going to be using throughout the rest of the show, because today we're going to see incredible distances. We're going to see distances of millions, billions, even trillions of miles or kilometers. And as we go farther out, if I keep using miles or kilometers to tell you how far we've gone, pretty quickly it's not going to make a whole lot of sense because the numbers are just too incredibly vast. So instead, from here on out, I'm going to use the speed of light to imagine how far we've gone out into space. So if we were traveling at the speed of light, the fastest speed we know of in the entire universe, it would have taken us about 1.5 seconds to get here to the moon from Earth. So we can say that the moon is a distance of 1.5 light seconds away from us. So traveling here would have taken about the same amount of time that it took us here in OpenSpace to get here, not super long. But let's zoom back out away from our neighbor over here, and we're going to bring up some blue lines similar to the yellow line like we saw before to show us where the orbits of the objects in our solar system are. So we can see there the orbit of the moon as it goes around the Earth. And as we zoom out, we'll see the orbits of the other planets in our solar system. There's Earth, and we'll see the orbits of the other planets as well. And in a second, I'm going to focus on the very center of our solar system, the closest star to us, the sun. So the sun is a distance of about 8.5 light minutes away from us. So it takes light about 8.5 minutes to get here. And there's a couple of ways I like to think about that. One way to think about it is that if the sun just disappeared, we wouldn't know about it for 8.5 minutes. Thankfully, though, there's no reason why the sun would just disappear. We don't have to worry too much about that. Another way I like to think about it is that if you walk outside and you look at the sun, first of all, please don't do that. That is very bad for your eyes. Never, ever look at the sun. But if you were to look at the sun, that's how the sun looked 8.5 minutes ago, not how it looks right now. And so here within these few light minutes of distance, we're seeing the orbits of the rocky, smaller planets in our solar system. Closest in, we've got Mercury, then Venus, Earth, and the orbit of Mars is out here. If I keep zooming out, we can see in the distance the orbits of Jupiter, Saturn, Uranus, and Neptune. And you may notice there's a pretty sizable gap here in between Mars and Jupiter, but that's not totally empty space. That's actually where we find most of the smaller rocky objects that we see in our solar system. This is where we find, which will load up in just a second. Maybe, there we go. This is where we find the asteroid belt. So not all of the asteroids orbit in between Mars and Jupiter here in the asteroid belt, but most of them do in this place we call the asteroid belt. But a little less well known is there is actually one object, which I'll bring up the orbit of here. There's one object in the asteroid belt that we call something other than an asteroid. So I brought up here the orbit of Ceres, which is one of the dwarf planets in our solar system. And if you've never heard of Ceres, don't feel too bad. Often people haven't heard of Ceres before, but Ceres is a dwarf planet, very similar to another very famous object farther out in our solar system. I will bring up the orbit of Pluto. Now, sometimes I like to talk a little bit about Pluto as well, because I still have people wondering about Pluto. People ask questions like, what happened to Pluto? Did Pluto get kicked out of the solar system? Did Pluto explode? Why do you hate Pluto? But I'm here to tell you, I do not hate Pluto. I think it's a very interesting place. It's one of my favorite places in the solar system, actually. But there is a reason that we don't call Pluto a planet anymore. As of 2006, it's been called a dwarf planet. And that has to do with where it is in the solar system. For example, when we first found Ceres over here in the asteroid belt, that was around the same time that astronomers were finding a lot of these asteroids. They didn't know about many of these asteroids before they found Ceres. So at first, Ceres was called a planet. Similarly, when we first found Pluto, we thought it was the only thing orbiting this far out in the solar system. But then in the late 90s and early 2000s, astronomers started to find a lot of other objects, a lot of which were out here by Pluto, and a few of which were roughly the same size as Pluto too. So instead of adding on more and more planets, people kind of took a step back and thought, maybe we should reevaluate here, come up with a different way to categorize the things in our solar system. Maybe we need to come up with a more specific definition of a planet. So back in 2006, a group of astronomers got together and decided that there are 3 requirements for a planet. Number 1, a planet needs to orbit the sun. Number 2, a planet needs to be big enough that its own gravity has pulled it into a round sphere shape, so it needs to be round. And number 3, it has to have cleared out its orbit. It needs to have a pretty cleared out orbit. Pluto did not fulfill this 3rd requirement. Pluto goes right through what we call the Kuiper belt out here. Doesn't have a very cleared out orbit. So Pluto was kicked out of the Planet Club back in 2006 because of this. But they came up with a new category of objects called dwarf planets, which are objects that are big enough to be spheres, but weren't big enough to shove all that stuff out of their orbits as they were forming. So some people think of this as a demotion, but personally, I don't. I think of it as just we learned more about our solar system, and that's what science is all about, is learning more and adjusting as we go, as we learn more about our universe and the objects that are out there that we can see with our telescopes and everything. But now that we are out here by Pluto, let's check in with how far we've gone out into space. So we've gone from the International Space Station, as far as humans travel out into space, just a few hundred miles above the Earth's surface. We went to 1.5 light seconds from us, the moon, the farthest that humans have traveled out into space so far. Then we saw the sun, which was 8.5 light minutes away from us. Now out here by Pluto, we're looking at distances of light hours. If we were to travel across Pluto's orbit from one side to the other, that would take us roughly 9 hours if we were traveling at the speed of light. So it would take about the same amount of time as like a nice long night's sleep if you were to go across a big portion of our solar system here. And this is a good spot to check in with any sort of human influence that we have out there in space, because we can check in with how far our spacecraft have gone. So I'm showing here the trajectories of the 5 farthest spacecraft that we have sent out so far. So these are Voyager 1 and 2, Pioneer 10 and 11, and New Horizons, which went out to Pluto back in 2015. And these are going really fast. These are some of the fastest spacecraft that we've sent out, and some of them have been going for a really long time. Some of these have been traveling since the 1970s for several decades now. But even so, even though these are the farthest and some of the fastest spacecraft that we have sent out, none of these spacecraft have gone as far as light can travel in a single day yet. So we're still only out to light hours at this point. We haven't quite gotten out to distances of light days. But we won't stop here. We still have a really long way to go on our tour today. So we're going to continue to zoom away, and we're going to go outside of our solar system. And when exactly we reach the edge of our solar system is kind of tricky. It's kind of hard to determine exactly where our solar system begins and where our solar system ends. There's a lot of stuff going around the sun. There's things that are gravitationally bound to the sun. We've got solar winds coming away from the sun, all sorts of things. So it's kind of hard to determine exactly where our solar system begins and where our solar system ends. But in a moment, we'll start to fly past other stars. So you can see down here, for example, other stars in our galaxy. And as we start to fly past other stars, there is no question anymore. We are definitely outside of our solar system, and we are in interstellar space, the space in between stars. And to check in with how far we've gone at this point, we've bumped up in distance quite a bit. So we were looking at several light hours, really far out in our solar system, out by Pluto or out by the spacecraft that we have sent out. Now, if we wanted to travel to the closest star to us out here, well, that would take you a few years, even if you were traveling at that fastest speed we know of, at the speed of light. So it would take about 4 years to travel to the closest star. So things are really far apart out here in space. There's a reason we call it space, because there's a whole lot of space in between things when you get farther out. And around many of these stars is a subject that I think is one of my favorite parts of astronomy, what is around these other stars, because we have found within the last few decades now, roughly, that these stars are not all alone out in space. They actually do have planets that are going around them. And I can show you where those are. 1 second. Here we go. Exoplanets. So these are showing us where there are planets outside of our solar system. So every single one of these blue dots is a star that has at least one exoplanet. And many of these have multiple exoplanets, just like our solar system has multiple planets too. And if you take a look at the bottom right over here, you can see there's a higher concentration of exoplanets over in that direction. And that's because that's the direction that the Kepler Space Telescope looked. So it just looked at one part of the sky for a really, really long time and found a bunch of planets over in that direction. So that's why there's a lot more over in that way. And right around here, as we start to fly past some of the closer exoplanets that we can see here, this is the last time, our last opportunity to check in with any sort of human influence that we have out there in space. Because we've already seen how far any objects we've sent have gone. We saw before how far our spacecraft have gone. So anything we're seeing from here on out is not because we've sent something to that place to take a picture or look at it for us. Everything we're seeing from here on out is because the light from that object has traveled to us and gotten into our telescopes. But there is something that we have been sending out for a while now, and we can see how far it's gone with this sphere here. This is what we call the radiosphere. This is to show us how far any radio or TV signals or anything like that, how far they've gone so far. And we've been sending radio signals away from our planet for about 90-ish years now. Back in the 1930s were the first radio signals to escape our planet. And so this radiosphere is about 90 light years away from us in all directions, because all of our radio signals are traveling at the speed of light. And if you look carefully, you can see that there are several exoplanets inside of the radiosphere. So who knows, maybe there are some aliens watching or listening to our radio programs right now. That would be pretty cool. Unfortunately, no luck finding aliens so far, but there are scientists that are searching for them. So who knows, maybe we'll find some around one of these exoplanets at some point in the future. But we're going to keep on going because we still have a really long way to go. We haven't even left our galaxy yet. We're still in the Milky Way right now. And as we zoom away, I encourage you to keep an eye on the radiosphere, see how long you can spot it as we zoom out farther and farther. And you can really see that kind of cone of where the Kepler Space Telescope saw all those different exoplanets over to the left there. And in a moment, we'll see a nice model of what we think our Milky Way galaxy would look like if we could go outside of it and take a look. Like I said before, we have not actually gone out this far. We have not sent anything out this far out into space. But we have a pretty good idea of what our galaxy would look like if we could go outside of it based on what we do see from it here. So this is a nice model of what we think our galaxy would look like if we could go outside of it. And you can see that little teeny tiny blue dot right there near the top. That is the radiosphere. That's how far anything we've sent out into space has gone, just that little area. Because now we're looking at distances of thousands of light years. If we were traveling at the speed of light, it would take us roughly 100,000 years to travel across our galaxy here. So this thing is gigantic. And we think our galaxy has a few 100 billion stars inside of it, and probably billions of planets too. We are finding planets around a lot of the stars that we find in our galaxy. But we won't stop there either, because our galaxy, the Milky Way, is just one galaxy out there in the universe. As we fly out, you can actually see a couple of dwarf galaxies that are nearby us. On the bottom right here are the Large and Small Magellanic Clouds, which are dwarf galaxies that are going around the Milky Way. But also all of these dots that we're seeing, these are all other galaxies. Every single one of those dots is another galaxy with its own billions or trillions of stars. And the colors of these galaxies may make you wonder, what are these colors? I'm sad to say these are not the actual colors of these galaxies, though I think that would be fun if it looked like cosmic Skittles out there in the universe. But these colors are because of the different data sets that these galaxies are part of. So what group of people or what telescope was used to map out those galaxies is how we've color coded them. And this is an actual map. This is a map of the galaxies that we have seen so far. So this is a real map of where they are relative to us. But since it is a real map, at some point it's going to look a little bit strange. There's a couple of things that are a little bit odd about our map here, because we are looking at all this from our kind of biased perspective from here on Earth. And let me get a good angle here so we can see the shape that these galaxies seem to make. So you'll see there's kind of a gap to the top left and the bottom right down here. And that is because we are looking at all this from our perspective here on Earth. And because of that, when we look over in those directions, if you could see the Milky Way galaxy, the disk of the Milky Way would actually line up really nicely with where those gaps are. Because when we look in those directions, we're looking in the same direction as our galaxy. So the dust and gas and stars that are in our galaxy are blocking our view, making it so we can't see the galaxies over in those directions. So there are even more galaxies than this, but this is just what we've been able to map out and what we've been able to see so far. And it also makes it look like we are right at the center of everything, right here in the middle of all of the universe. But as far as we know, there really is no center to our universe. If you were in any of these other galaxies and looking out, it would also look like you're right at the center with everything moving away from you in all different directions. So that's another thing that's because we're looking from our perspective. It looks like we're at the center, and it looks like it makes this strange kind of butterfly shape with the galaxies. And now that we're out here past many, many thousands of galaxies, there are billions of galaxies out there in the universe, we have gone a very, very large distance. So we were looking at a distance of 100,000 light years to go across the Milky Way. Now we're roughly a few billion light years away from Earth at this point. And we're also looking back in time, because when we're looking at these objects that are really far away, we're kind of time traveling in a way, because all this light takes so long to get here that by the time it travels all that distance and gets into our telescopes, we're seeing the light of these objects as they were in the past, not how they look right now. So if you remember at the beginning of the show, I talked about if you looked at the sun, which again, please don't look at the sun, but if you looked at the sun, that's how the sun looked 8.5 minutes ago. Well, this is what our universe was like billions of years ago. And because of that, that means there is only so far that we can go. There's an edge to everything we can see in our entire universe. And that edge of our observable universe, as we call it, is all over the screen now. This big orange thing that we're seeing is the cosmic microwave background. Now, when you walk outside, if it's a nice clear night and you look up at the sky, you're not going to see this everywhere you look. Thank goodness. If I looked up and saw orange everywhere, I would be a little disturbed. But if you did walk outside and you looked up with microwave vision, if you could see microwave light, which is a lower energy form of light that our eyes can't see, but our telescopes can, you would see this every single place you look in the sky. And this is a few 100,000 years after when the Big Bang would have happened, when light was first able to go out and expand out in all different directions. So before this, light was just kind of trapped in a small, hot, dense area, couldn't really go anywhere. But this is showing us the moment that things cooled down and expanded enough that light was able to escape and go out in all different directions. So an easy way I like to think about it is that this is the baby picture of our universe. This is the earliest light that we can see. And the differences in color that you're seeing are very slight differences in temperature and density in that first light of our universe. But since this is the earliest light of the universe and as far out in space and time as we can see, that means, well, we can't really go any farther. So to end our tour today, we are going to fly on back home. Now, keep in mind, if we were really this far away out in space and if we were really traveling at the speed of light, this journey home would take us more than 13 billion years. But thankfully, we're using our lovely planetarium software, so it should only take us a couple of minutes or so. So here we go. And as we fly back home, one thing I like to leave folks with is that all of this that we've been looking at, stars, galaxies, cosmic microwave background, planets, dwarf planets, gas, dust, everything we can see, that is a very small portion of everything we know to be out there in the universe. there are some really mysterious things like dark energy and dark matter. Dark energy is some mysterious force that is causing space itself to accelerate as it expands. Dark matter is some mysterious substance that doesn't seem to interact with light at all, but we see evidence of it in between and at the edge of galaxies, especially. And we call these things dark energy and dark matter because we're not quite sure what they are, but we do know that they make up about 96% of our universe. Ooh, and I have a question. Let me finish up what I'm saying and then I'll answer that question real quick. So all of this that we can see is a very tiny portion of everything we know to be out there. Let's see. Did the New Horizons spacecraft detect any evidence of fresh craters on Pluto formed by the Oort cloud object impacts? Ooh, that's a very interesting question. So the New Horizons spacecraft is one of these spacecrafts that we'll see as we fly back in, one of our farthest spacecraft. And it did fly by Pluto back in 2015, got some lovely high resolution images for us. I don't know if it noticed any fresh craters, but I do know that New Horizons found things like glaciers on Pluto. We found out that it has water ice mountains. We found out that Pluto has an atmosphere. So we learned a lot from New Horizons, but I don't think there were a lot of things that were new on Pluto, like things from the Oort cloud or elsewhere in our solar system aren't really hitting objects quite as often as they used to. So I don't know for sure, but I do know that we learned a lot from the New Horizons spacecraft. So thank you for that question. But speaking of New Horizons, that is one of the lines that we are seeing as we fly back into our solar system here. And we are going to end our journey where we started it, back home on Earth, where we can watch all this from and learn about all these amazing different places from our own home, safe little home, our little blue planet here in our solar system. And we are back home. Hooray! So with that, I want to thank you all for joining me today for our tour of the universe. I hope you enjoyed flying around in space with me. And next time you're in Golden Gate Park in San Francisco, you should be sure to come to the Morrison Planetarium and see a show. We've got our tour of the night sky going on right now at the end of the day at 4:30 every day. And we'll bring back a tour of the universe later at the beginning of next year sometime. So be sure to look out for that. But with that, I hope you are all staying safe, staying healthy, and I will see you another time. Thank you so much for coming.